Hi, my name is Cameron,
My name is Marcos.
and today we're going to be talking about the physics of exercise. Now, physics can be applied to basically any exercise you can think of. Some examples are the motion of running, of the swimming force versus a current in, let's say, a river, or lifting heavy objects and how much net force your muscles have to apply to lift and exceed the force of the object. But today we're going to specifically be talking about the leg extension machine and how much force and torque it takes to use that, and the simple overhead press. Alright, so this is our leg extension machine problem. This is our leg extension. We got the leg coming down, and then this is our weight right here. And then our force diagram shows that the force of the leg on the weight is going to be pushing upwards, and then the force of gravity on the weight is pushing that weight downwards. This is just a visual representation of what the leg extension machine looks like. So we're going to start off with our known, and that would be the weight being pushed is 60 kilograms. So we know that, and then the distance from the muscle that forces the leg upwards to the pivot point is 60 millimeters. So that would be 0.06 meters. And then the distance from the weight to the knee, which is our pivot point, is 0.46 meters. So now that we have our knowns, we're going to start off with the force of the weight. So to do that, we're going to take the mass of our weight, multiply it by gravity, and that's going to give us our force. So that's 60 kilograms times 9.8 meters per second squared, which gives us some of the force of 588 newtons. So 588 is our number for the force of this weight. So for the leg extension machine to work, you have to bring your legs up and then slowly let it down. So we definitely have to have more force than at least 588 to get this weight up and to perform the exercise properly. So to do that, to find out what it's going to take, we're going to use our sum of torque equation and then take the negative value of our force of the weight, multiply it by the distance from the pivot point that the weight is, plus the force of the leg, which is our unknown, that's what we're trying to find, and then multiply it by the distance of the muscle from the pivot point, and then all equals to 0. So just going to plug and play here, a little bit of algebra. Negative 588, that comes from our force of the weight, multiplied by its distance from the knee to the weight, which is 0.46 meters, plus the force of the leg, our unknown, multiplied by 0.06 meters, which is the distance from the muscle to the pivot point. So then solve for that, still equal to 0. We're going to get the 270.5 on that side, and then get our 0.06 in force alone on the left side. Divide that by 0.06, and then we get our force of the leg equals 4,508.3 newtons. So that's just the minimum amount, that is the amount of force needed to keep that weight at a static point. So anything greater than this force, then your leg starts to go up, and that's when you actually perform the exercise.
Our next workout is a shoulder press. And we have drawn the quick force diagram and a motion diagram for the force for a shoulder press. Of course, we have force of the earth on the weight due to us lifting the weight over our head as our rep. And also we have the second force acting on the weight is the force of the person, which is yourself, pushing the weight upwards. Now for a motion diagram, we have two different motion diagrams due to the movement of starting at the bottom, going to upward motion, and coming back down in a downwards motion. For our upwards motion, we have a accelerating motion accelerating until you reach your top point. And for the downward motion, we have a decreasing, downward increasing motion until you reach the bottom. Now, remember, this is very important for a shoulder press to have really good form due to the high risk of your shoulders. You need to have arms out wide, shoulders spread wide, and just up. Let's talk a little bit more about the shoulder press and the correct form of a shoulder press. The ideal form of a shoulder press is 90 degrees, which is just an upward motion like this. Two discorrect forms a lot of people do while doing this workout is an 80-degree motion and a 100-degree motion. 80 degrees just being like this. That really doesn't work out your shoulder. It's more of a chest area workout. And over time, you're just wasting your energy, and being at the wrong motion could affect your shoulder. Now the 100-degree motion is the worst one compared to the 80 due to how lean back your shoulders are and rotated. Adding force in this position will severely injure you and your ligaments.
This shoulder press is too far forward. This is a perfect 90-degree angle. And then this one, his shoulder blades are leaning too far backwards.
Now, it's very important that you continue to do the 90-degree motion during this workout, because even the slightest change of degree between 88, 91, doesn't matter, over time will affect your workouts and injure your muscles.
Alright guys, now that you've seen our two specific examples of physics being applied to exercise, which is the leg extension machine, specifically how force and torque can affect how much weight you can put up, and basically just how that machine works. And then, as Marco showed you guys, the shoulder press, the motion and force, and how to prevent injury.
Remember guys, it's important overall to have good form in your workouts to increase muscle growth and in the long run avoid injury. Thank you guys for watching.
Thank you.